Let's talk about moving between quadratic forms. We know that we have our standard form, our vertex form, and our factored form. Let's first cover how to move from factor to standard. If you have something in factored form, it might look like x plus 5, x minus 7 equal to 0. Now let's say you need to go to standard form or expand it. They might say which expression is equivalent to, da da da. You have one of two methods. You could either use FOIL or box method. Now, I think that box is superior to the FOIL method for a reason that I'm going to get to at the end of this video, but I'm going to show you them both. FOIL stands for first, outside, inside, last. First, outside, inside, last. For example, for first, that might be the x and the x. For outside, that might be the x and the 7. For inside, it's going to be the 5 and the x right here. And for last, it's going to be the 5 and the negative 7. First, to do first, we multiply x by x, that's going to give you x squared. Then we do outside, x by negative 7, that's going to give you negative 7x. Then inside, plus 5x. And then last, negative 35. And then I combine my like terms, which are going to be these x terms. So that's x squared minus 2x minus 35. And that's it. Now, to go for my favorite version, which is the box method, you're just going to assemble a box like this. And then you're going to put your factors in the box. So it's going to be x plus 5, x minus 7. And then it works the same way, where this is first. First goes here. In this case, outside would go here. Inside would go here. And then last would go here. We have first is going to be x squared, 5x, negative 7x. And this is going to be negative 35. And as you can see, then we combine these boxes right there. And you're going to end up getting x squared minus 2x minus 35. The main reason that I like this box method better is because the box method is going to scale with your skill set. So for example, let's say that instead of doing a binomial by a binomial, you were doing x plus 2 and then x squared minus 4x plus 5. The problem is that FOIL, now that I have a binomial and a trinomial or anything else, FOIL doesn't really work because do I do first, outside, but what's my inside? Is that my inside? Then that my inside? And then last, is it only this and this? But then I feel like I've missed first in the middle. You know, you miss certain things as opposed to the box method, which now I do make the same grid. The only difference is that I have a grid now with 3 terms. So I have my x squared, I have my negative 4x, and then I have my 5, and then I have x and 2, but still now it's able to scale with me. 2x squared, negative 4x squared, negative 8x, 5x, and 10. And then typically you're just combining across the diagonals for the same term. So I'd have x cubed minus 2x squared minus 3x plus 10 if I were to factor out this x plus 2 times x squared minus 4x plus 5. I can expand that out. The box method scales with your skill set. All right, so that's from going from factor to standard. If we're then trying to go from standard to factor form, that's going to use the factoring quadratic methods outlined in this video. Okay, there's 3. There's going to be the x factor. There's simply 2 numbers. Your solutions add up to your b term and they multiply to your a times c. Now sometimes we may need to go from standard to vertex. That might look like something like this. Let's say I get x squared minus 6x plus 21. Now what I'm going to do is I'm going to take half my b term. So that's step 1. Take half your b term if you're going from standard to vertex. And that's going to become the constant inside of a parentheses group that I'm going to square. I'm going to create a perfect square out of this. Now really, if I were to do x minus 3 and I were to square that, I would get x squared minus 6x plus 9. That's what this really equals, which means that I've added a 9 somewhere in here, but it's just invisible. So I've added an invisible 9 that you just don't see, which means that I have to subtract 9 from the same side. In this case, I would do 21 minus 9. So that would give me plus 12. And my vertex form would now be complete. So I would do 1, take half b term. That becomes my constant in the perfect square. So then after you take half of that term, square the term and subtract that from the same side. That's it. That's how we go from standard to vertex form. So let's do one more real quick. X squared plus 10x plus 5. I take half my b term, which in this case is 10. So I got x plus 5 squared, and then take that 5, square that. That's 25. Subtract 25 minus 20. That is my vertex form. Now let's say I'm going from vertex to standard form. I start off in vertex form. Maybe it's x plus 4 squared minus 6. All I'm going to do is focus right here on my perfect square. I'm going to get x squared plus 8x plus 16 minus 6, and then combine my like terms. So that's going to be x squared plus 8x plus 10. If this was the vertex form that I started with, now I am back into standard right here. We've covered going from standard to vertex, and we've also covered going from vertex to standard and back again. There really is no easy way to necessarily go from factored form to vertex form. So typically we just have to go through standard form either way to kind of connect them. But that's pretty much how we move between the quadratic forms, how you do operations with some of your polynomials. So using FOIL, box method. Box method is the best. Box method is the best.